Welcome to a bonus video on synthesis. We're doing the 2021 Part 6, Question 2 here. Okay, so the first thing I do is I kind of take stock as to what has changed. I have added SH there, and I have done some kind of elimination reaction. Okay, so now that I know roughly what I'm going to need to do, well, let's see, how am I going to do this? For adding SH, I might recognize SH as a fantastic nucleophile, SH minus as a fantastic nucleophile. So if I throw a leaving group on this, then I'm going to have a great old time, and that is going to SN2 perfectly. So I like that. For elimination, similar type of thing. I'm going to need to add some kind of leaving group to this. And then I'm going to need to do an elimination reaction. Okay. Does it matter the order that I do this in? Well, let's see. If I eliminate first and then add a leaving group, is that going to SN2? Yeah, it's going to SN2 pretty well. If I instead do my SN2 first, am I going to be able to eliminate? I might get some weird deprotonation or something on this sulfur, because it's actually a stronger acid than OH, right? So really, either way is probably going to work out okay, but I think I'm going to eliminate first. It's going to be step 1. Step 2, there. Okay, so let's eliminate here. We have many options. We could put a bromine there. We could put a chlorine here. Either of these options are going to work out just fine, actually. So I like bromine, so I'm going to start with that. But either way, you can make it work. What do I want to use? I'll use NBS this time. It's a fun one. So that is going to put a happy bromine there. And then I need to do my elimination reaction. Now, this thing has lots of symmetry, so it doesn't matter which proton I pull off. To match the diagram, I'm going to pull off this one. You don't need to show that on this. I'm showing it to you for explanatory purposes. And now I just need to do an E2 reaction. So, which base do I want to use? Since this is tertiary, I can even use just sodium hydroxide. I don't have to be fancy here. I'm not going to have to worry about any SN2 side products. So sure, why not? I'm just going to use sodium hydroxide. If you used a stronger base, sodium amide or Lin, that's totally fine too. Any of those are good. And that's going to give us our structure here. Okay, so now what we need to do is we need to radicalize this thing. Okay? We need to put a radical on one of those positions. This is also going to be just fine. We can use any number of things here because these positions are terribly unstable to put radicals on. This is your vanillic position. Remember, think vanillic, think like someone who's drank a lot of wine. They are really unstable. This position doesn't even have a hydrogen we can pull off, so no sweat about that. I'm going to use some chlorine though, just cuz. So we're going to say chlorine and UV. Again, if you used NBS, totally fine. If you use bromine, totally fine. And I'm going to get my chlorine. Fantastic. Does it matter if it adds up there? Nope, that would also be totally fine because of symmetry. Okay, now we need to add SH minus. We can do that pretty fine. We don't even have to do anything weird to it because we're allowed to add anything that does not contain carbon. No carbon there. So I'm adding my good friend Nash, but as you know, the sodium pops off. And now we just have our amazing nucleophile. So it's going to E2 its heart out. So, excuse me, SN2 its heart out. And we're going to be left with that as our final product. Let's just make sure this matches. It matches. Hey, fantastic. All right, I hope that was super helpful. Good luck on the rest of your studying.